All right. Thank you everyone for coming to today's presentation. This will be a short course webinar series, and we're going to be specifically targeting contamination control. This is part of the series that we've been running all summer. Mine is the next one up. So I'll introduce myself. My name is Drew. I am the Director of Training here with Fluid Life. I've been doing this training side of things for a number of years now. I'm going into my 7th year with Fluid Life. I've done a bunch of training. I'm the one who mainly goes to these sites and does the site audits for site visits, or help customers decide how to properly grease, how to properly take samples, and even to the point of running around and showing our customers how to draw samples from each type of asset. So we'll do 4 different topics here. Contamination sources, control strategies. We'll do a quick overview of what contamination is. We'll follow that up by where we find these contamination sources, ways we can help control them, and then some touching on filtration. And I guess one thing I'll ask you guys, if you guys have any questions or comments, just please hold them to the end so we can get through the slide deck, and then I can give you guys all the information you guys need. So most of our failures are going to be a cause of some sort of surface deterioration. Most of that is going to be some form of particular contamination, whether that's wear metals, that's dirt, that's even fibers from cleaning rags. So what will happen eventually over time is can cause wear metals to generate. The biggest ones that we see, or the most that we usually see, will be some sort of adhesion or abrasion type particles. Now, adhesion, what I mean by that, I'm just going to touch on this quickly, is essentially the surface is sticking together. So think of it in terms of you put a piece of tape on a piece of paper and you rip that tape off, and that like paper fuzz that ends up on the back of the piece of tape and that remains on the piece of paper, that's what we see as the term of adhesion. So if you hear the term smearing, seizing, galling, sticking, any of those kind of type of any type, I've just lost my train of thought there. Sorry, any of that kind of nomenclature is what we're going to see for adhesion. Whereas abrasion, you see scratching, scoring, cutting, any of those kind of ones we would consider abrasion. Now, what exactly is contamination? Well, as I stated here, contamination is to make something unfit for use by the introduction of unwholesome or undesirable elements. That could be from external contamination, dirt, dust, water. For example, as you see on my pixelated picture here, the barrels of oil that are stored terribly, and you can see all the dirt and the dust and the coal in the bottom there. This was actually taken at a customer site, and this was outdoors, obviously, under lots of rain, lots of dirt, not an ideal situation. Now, self-generated contamination, that could be built-in particles, wear particles. And funny enough, we just had one of our employees just purchased a new vehicle, and he did a 2,500 kilometer oil change on it, and it was full of sand. And we look at it, silica sand. In all probability, that was likely due to the casting sand. Wear particles, that could be from the wear metal as generated from the break-in side of things, or even the dirt that would cause them. Chemical contamination, that could be mixing of lubricants. And when I mean by mixing of lubricants, is like mixing gear oil and engine oil. Big no-nos. You don't want to be mixing these different oils because they have very different additive packages that do very different things. In additives, don't be adding those third-party additives to oil unless it specifically says by the lubricant manufacturer, hey, you can add this additive to help with this property. In most cases, the additives actually are far more detrimental than they are beneficial. So the biggest thing when it comes to oil and starting out is Cleanliness and contamination control are going to be the most important aspect of your proper lubrication for long equipment, lifelong lubricant life. If it's dirty going in, if it's not good or full of dirt, full of water, any of those kind of things, is going to be you're starting basically in a deficit already. So making sure that we have everything aligned and good is going to be greatly beneficial. We need the right viscosity package, the right additive packages. This is going to help maximize our oil life. This is also going to be done by keeping the correct oil in the machine, keeping it clean, keeping it cool, and keeping it dry. And by what I mean is just having it in a temperature controlled environment to store your oil. And like I said, most of our failure is going to be attributed to some form of one of these forms of contamination. Now, when I was talking about my colleague having a new vehicle and the oil appearing clean, well, technically, according to API standards, if you can't feel or see dirt or particles, it's considered clean. Now, to give you an idea how big that would actually be, is take a piece of paper and look at the cross section of it. 40 microns. So that's the smallest that we can see. Now, for those of you who look at any sort of oil analysis report, whether it's Fluid Life or any other vendor, the ICP, the inductive coupled plasma machine that tests for all the elements, it only measures up to 5 microns in size. So you're not going to be seeing any of these particles that appear to have in a clean machine. Excuse me. Same principle goes for water. New oil can be much dirtier than what an OEM recommends. This is especially important for highly critical equipment such as hydraulics, turbines, and such. Now, small particles, they can typically pass right through an oil film, and that's why we have different viscosity grades of oils. But we want to make sure that our oil is as clean as possible going into that machine to help the longevity. So it can be up to 8 times dirtier by most manufacturers for our oil. And we'll get into that a little bit shortly. So how clean do we really need that oil to be? Well, like I mentioned, the critical particle size that must be controlled is typically anywhere between 1 to 5 microns in size to maximize their component life. Now, typical oil filters for like your vehicle are probably around 40 microns, but the constant circulation and filtration of a circulating system allows those particles to get picked up. Now you can see some of these components here, how important it is to make sure that we have those proper clearances. Think about it in terms of the older vehicles that we've driven in versus new one, and even newer and older industrial equipment. How thicker oils was a very common practice before. Now most equipment now, we'll use a sedan car for an example, like a Toyota Corolla. I believe it runs an OW16 oil. 30 years ago, that's probably running a 5W30 oil. So very much tighter clearances between these components, and you need oil that's able to get in between these clearances, that's able to flush out the particles. So when it comes to bearing life and really driving down the importance of making sure we have clean filtered oil, if you look at this, the 40 microns here, the 40 microns in size, like I said, that's the smallest that we can see, versus like where we see a lot of particles, like we said, the 5 particles, that's 5 microns in size, that's the smallest that we can see, or sorry, the instrument can see. The largest the instrument can see, excuse me. So you can see if we can filter into this, even in this 10 micron range, we can maximize our component life quite a lot. Same type of principle goes for water. So when I talk about this, it's imperative to know how water has a huge effect on our equipment. Now, there's a couple tests that we do for testing for water, as do most oil labs. Now, there's crackle test. Crackle test measures oil. Basically, it's slapped onto a hot plate, and you look for it to bubble and pop. And that is usually only detected at about 150 to 200 parts per million. Now, if we look at our chart here, well, about 150, so 0.02, right? We're already at about half a bearing life if we are waiting just for that crackle test to show up. That's why there's more advanced tests, such as the Carl Fisher test, which can test down about 10 parts per million of water. So drastic difference in that. Now, it's not necessarily how much dirt you have in your components, but the size of it. So even one single little particle can jam up an entire system, called the silt lock, valve restriction. So ensuring that we're able to have the right viscosity of oil that can flush out those particles is going to be important. Kind of getting on to kind of can see what I'm saying about how important it is to have that clean oil from the beginning, especially for systems that don't have some sort of online filtration system. It's going to be even more imperative. Filtering that oil before it goes into the machine is going to be a huge benefit. So the ISO particle count. So this is going to measure how many particles are in our oil in 1 milliliter, in a 1 millimeter sample, excuse me. Now it returns a code of R4, R6, R14. And that's just based upon the micron size. So we're going to see how many particles are 4 micron or bigger, how many are 6 micron or bigger, and how many are 14 micron or greater. And now why those three numbers are used, that's the ISO 4406 standard. That's just what the standard is. That's what they recommend. Now, the reason they use this, it's a heck of a lot easier to give you a code based upon a range as opposed to three random numbers. So, for example, in my exercise here, 21, 36, 463, 63. A little bit confusing. I mean, yeah, I could be saying the same thing. What if it was 1800, 460, right? That number is very daunting, just like the one you see on your screen there. Now, instead of giving you these random numbers, ISO decides to have a range number. So that's where we get like an 18, 16, 13. And now 18, 16, 13, that's a pretty clean standard for gearboxes. There's a number of different standards. So something like a gearbox would be an 18, 16, 13. A hydraulic system will be like a 16, 14, 11. These are just basic industry standards. Every component may be cleaner or may allow it to be dirtier. But if you want a good average number of what the ISO standard says this is good, go with that number. Obviously, cleaner is always going to be better, but you also got to take into consideration law of diminishing returns. Is it really worth cleaning it more and more and more? And the best way I try to attribute to is think of something like a loam sifter or like a rock sifter where you have lots of pebbles and medium-sized rocks and big-sized rocks. So basically, you shake it and it separates into different buckets. Now, that's not what we do with the oil, obviously. The oil passes by a sensor and it'll see how many times the light is blocked. So whether that's dirt, whether that's wear metals, and even something like I mentioned before, like the fibers from cleaning rags, or something like water or air. So there's examples where we have customers where it looks like the oil's super clean, but then their ISO particle ISO particle count is way off the charts. And then it's like, oh, well, let's go look at the water. And there was a ton of water in the sample. So using all aspects of your report is going to be what's important. You can't just be looking at, I see some wear metal, but then there's not actually an issue. if you see a bunch of water and you don't see other things highlighted. It's could be other factors going on. So making sure you read the entire report is going to be what you need to have a good understanding of your report. Another example would that be is you could have an engine that has a ton of soot in it, and it would be thickening up the oil. But you could also have a bunch of fuel in there that would be thinning it out. And if you're looking just based on your viscosity, well, those two can almost counteract each other, and your viscosity would be fine, but everything else is off out to lunch. So making sure that we look at the whole report holistically. Next step, contamination sources. So as I mentioned before, you get self-generated contamination, your external contamination, and your built-in contamination. Just like I mentioned, my colleague with his vehicle contamination, anything that comes in from the air. I mean, you open up a fill cap, you open up that barrel of oil to put in a drum pump, or even the breakdown of the components, because oil is going to break down, whether it's premature from overuse and working too hard from operations, because as we know, operations, right, they wink wink, they never operate anything over past its limits. And then any sort of wear products from components, we know there's going to be break and wear. We expect there to be wear components in, especially in something like a gearbox. There's the wear components is just part of the natural process of how the equipment operates. So the main ones we typically see will be some sort of metallic wear, chemical corrosion, oxidization residue, and oil-insoluble substance caused by mixing of oil. So I could go on with all these types of metallic wear for an entire training course, and I could fill your guys' ears with metallic wear knowledge for 2 days. My background is metallurgy, and I am going to talk about it for about 2 minutes per slide. So adhesion, as I mentioned, smearing, seizing, galling, any of those types of terminology is going to be what we see for adhesion. So you're going to basically see like what looks like strings of metal in your oil. This bearing race is obviously severely damaged, and severe adhesion has gone on. Something like this is probably from a glycol washing out or fuel washing out the cylinder and causing extensive damage. Now we see the wear metal here, the strings of metal. These are probably 10, 20 micron in length and maybe a couple micron in width. So these are actually not that big of an issue. Now, equipment gets old and broken, as do we all. So what happens with fatigue? It typically occurs when a piece of equipment has been overloaded. So equipment, especially something like roller bearings, they go through elastic deformation. So elastic deformation is when it gets load pressed onto it and it compresses, like for example, the roller elements, and then it goes actually back to its same shape. That's just the natural cyclic loading of elastic deformation. Now, if something gets overloaded or you get a hard particle or something in there, it's going to cause plastic deformation. And plastic deformation means permanent rupture of the shape. So what happens is every time you go over that same spot, it's going to propagate a crack further and further and further until you have a stress concentration like you see in this graphic here, and it'll break off and cause little flakes in your oil. And that can actually cause more damage, right? Because now you have a hard particle in there that can propagate more fatigue crack or cause abrasion to occur, or adhesion where it occurs. So taking in consideration all these kind of things just to ensure that equipment is properly lubricated, properly filtered, and stays within the design parameters for operations. Abrasion wear, so scoring, scratching, any of those kind of like removal or plowing of materials. So it kind of looks like metal swarf here, right? Like you find on the on a machine shop floor. Well, again, just like these particles and these particles, these are a few micron in length, so far smaller than you're going to see. Now, if you start seeing particles, you know they're large particles, but these photos are taking at high magnification, and we see there's clearly some significant wear occurring. Now, what'll happen is, again, hard particle gets in there, and it's just going to gouge out the material for our components. Very common in something like a gearbox. And again, gearboxes are designed to shed that material. And that's why we have things like mag plugs, and why we should be filtering our oil. And for those who attended the oil sampling one, why we don't sample on drain plugs, because all that particles are just going to sit down there, and you're going to have very erroneous result with your samples. Chemical corrosion. So this nice rusted soup, this could be caused by, well, this one here, as it's iron oxide, leads me to believe there's some water in this gearbox, and maybe a lot of water, actually. So other ways we'll see it is oil that is not compatible with the metallurgy of the equipment in question. For example, a worm gear drive will typically have that brass component on it, and brass has copper in it. And what happens is a good majority of our gearboxes have this extreme pressure additive that has an active sulfur in it. And what happens is, when it's under heavy load, as we see in gearboxes, this extreme pressure active sulfur activates, as the name suggests. And what it'll do is the soft metal will actually leach out the copper to the sulfur. The chemical reaction occurs, and it causes significant damage to gearboxes. Obviously, you need to have the proper gear oil in a gearbox that would have a soft metal. Hence, mixing of lubricants, bad idea. Adding additives, bad idea. For example, like an EP additive will actually have a huge effect on the rust and corrosion inhibitors, like you would see in this here. Rust and corrosion inhibitors obviously not necessarily doing their job there. Oxidization residue can be black or dark hard, dark brown, black or dark brown, and they're very hard and lustrous, and it's very difficult to remove this. Anyone who's ever worked on an old car or an old piece of equipment, I'm sure you've opened up a piece of equipment and seen this kind of disaster that can occur. And this is just old burnt oil, essentially. That's just the long and short of it. So high temperatures, oxygen, wear metals, excuse me, they all heavily increase the oxidization rate. Even water can as well. So generally, a good rule of thumb to follow is above 60 degrees Celsius, every 10 degrees Celsius that you jump up, you double your oxidation rate. So for example, if you have a gearbox that's designed to run at 60 degrees Celsius and you're expecting 1,000 hours out of it, if that thing's running at 70, you can expect to get 500 hours. If it's running at 80, you can expect to get 250 hours out of it. Now, again, this is just general blanket statement on how the oil itself works. There's obviously many other contributing factors to that. So external contaminations, airborne contamination, moisture contamination caused by adding lubricants. So like I mentioned, open up a breather, oil is going to get in there, get circulated. You're going to need to breathe air into that reservoir. So you need to have caps and breathers. And for the odd time you see that open piece of equipment where people think, oh, you don't need the cap on here, it's not that dirty. Even during an oil change, you're opening up that component to the atmosphere, right? Look at something like this stock image of a haul truck getting loaded, right? That dust there, if caps are not in properly, and even looks in this here, looks like that access panel is open. What if there's something that is allowing the contamination to get in there, right? Making sure things are closed and dampened and everything as it's designed to help prolong and make things last as long as they can. So taking taking a picture with the camera with a flash, walking into this area of the plant, look fine. Pull out your camera, take a flash, big difference, right? And you can see like all the products sitting on this. Like, yeah, obviously this is some sort of a bark or pulp mill or lumber mill. Now, all this, when I saw all this product on there, my first question is like, okay, well, obviously this is an issue with all the contaminant on there, but it's excuse me, two factors here. What about when we see in certain plants, and those of you in this webinar here who work in plant environments, if there's conveyors, and how often is there something like a gearbox on the underneath the a conveyor, and it's just covered in material, like it just basically it looks like a pile of product, and then there's really a gearbox under there. So you're kind of creating an insulating blanket on there, right? So what did I say about increased temperature on your oil, right? Where you're basically insulating it, you may be prematurely oxidizing that oil because it's getting warmer than it really needs to be. This one here is always a good little story that I like to tell. So this here, Spartan 220, it's a thicker oil, right? And so the technician in this picture here, he had punched out the filter screen on the tank here because he said it was easier to pour oil. I'm like, clearly you did a good job of pouring because it's all over the components and on the ground. But he was using those galvanized buckets. So for those of you who are using those galvanized buckets, please don't. They're awful. They're full of contaminants. You're better off using a funnel. And then my issue with a funnel is we all know what happens with the funnel. A funnel gets used and it's maybe wiped out, and it's used for multiple lubricants and different lubricants and maybe other different fluids, and it's fired on a loop cart or a loop truck and then reused again. And again, probably not wiped out. So let's try to make sure that we're doing the proper ways of cleaning it out. Now, you can buy those breather kits. For those of you who did the oil sampling may have seen. So basically what it is, a breather kit. I'm going to try to draw on this slide if I can here. Do a terrible drawing if I can. So basically what happens is you have a tube that basically is at a fixed depth that goes in there, and then you got a proper cap on here, and you'll have a breather, desiccant breather on there, and some of them even have a place where you can quick connect to fill, and on the other side is a place that will draw that oil sample up, and you're always sampling from that exact same spot every time. So I do apologize for my terrible drawing, but that's the best I can do for this right now. And then other ways we can see contamination sources. So all of these pictured containers, were used to transfer oil. We have the gasoline containers that now say EP220. We got our star of our show here, our Sunlight. We got brake fluid. This is EP220. 10W30 bottles that say EP220. I think the only thing worse is if he would have had something like a bug spray container to add oil to the equipment. Now we know what soap does to oil. It displaces oil and grease. So the fact that he's using something like that to add oil is illogical. Now you can buy different size proper transfer containers that have different orifices that will be the right size for adding it to pieces of equipment. So seeing something like this here, we have 1, 2, 3, 4, 5, 6, 7 totes of, cans of grease here. Now, this here is the oldest. We looked at all the labels like, so the first problem here is first in, first out. Use your oldest stuff first. That allows us to properly cycle our lubricants. Now, the other thing here is just poor housekeeping practices, and I'll give most guys the benefits of the doubt when I go on these audits, because it's like they don't know, they weren't properly trained on things, and I'm like, well, this is proper housekeeping. You can see the grease pouring down the side of it, and the other thing is it was overfilled. It's a little difficult to kind of see from the photo, but it was overloaded with grease, and the cap is just loosely sitting on top of a pile of grease. And he explained to me that his logic was that it would close in on itself. And he was hand bombing grease with this glove, which probably came with the sunlight container here. So I have no problem hand bombing grease. Just use something like disposable nitrile gloves or something. Don't be reusing a glove and leaving exposed. Grease is especially susceptible to contamination. It's not like oil where you can have dirt and drop it out of solution, where grease just holds everything there. Lube oil, I don't know what lube oil is. Is it gear oil? Is it hydraulic oil? Is it engine oil? Let's make sure that we're properly labeling things. Lube oil doesn't really tell me anything. So I kind of try to underline it and put a question mark, and obviously it didn't work out that well. The other thing with galvanized is galvanizing has zinc in it, and zinc can actually draw the zinc coating can actually draw the zinc out of the oil can actually draw the zinc out of the coating, and then you're throwing out your additives. So zinc is part of an antioxidant package, and so if there's zinc, it's going to try to pull that out as well. The one on the right, that could be two mixed oils, or it could be a mixed oil and grease. It almost looks like a soupy mix of you'd find on the bottom of a tank of oil or whatever. Just I don't really suggest mixing oils and greases for that reason, or two different oils, because it can be a real disaster. So mixing of greases, all these greases, they are fairly close in color. And what about under very low light? You might mess them up, right? They can be very different greases for very different purposes. The oils in the grease may actually be compatible, but the thickeners may not be. And it's a real simple test. We've had customers do it before, where you take two different greases and you try to mix them together on even just a little a plate or something. And sometimes they can blend properly. Other times it almost becomes like a really hot bubblegum stringiness and very hard to work with, or they almost becomes like concrete. We actually had one of our sales guys, he used to work with commissioning equipment, and one of his customers, they had the centralized lube system, and they put the wrong grease in centralized lube system as a top up, and it actually jammed everything up. They had to remove the entire system, push out all the pins and bushings to clean out the entire system on a brand new piece of equipment. This one here is kind of an interesting head scratcher. So the oil transfer can here, the technician claimed that he sealed the can with a rag, and it was a bit of a logical statement. As you can see, I removed the rag. You see all the chunks of dirt in the bottom. The problem with that is he told me that he wasn't worried about the chunks in the bottom because he never poured to the bottom of the can. Therefore, the chunks would never come up. I mean, not much thought process into that, but all those particles, they get kicked up. And what about all the little particles you're not going to see, right? That can just get poured into the machine. So just using the proper transfer containers. So water, it also has a huge effect on it. Free water, where you see the water and oil separated, that is called free. It increases your viscosity. Emulsified, where you have that mixed creamy color, right? Milky color. That's going to increase your viscosity. And dissolved, you're not going to see your oil. The water in the oil. It just very slightly decreases your viscosity, as opposed to something where emulsified and free can significantly. And as your oil gets ages, your additives that get consumed, more likely it is to hold on to water. Something like this is why we have our different oils, and like something like a Arno oil, right, or hydraulic oil, very little additives, because water tends to gravitate towards highly anodized oils. Now, something like a motor oil, we're not too worried about it because motor oils have things like emulsifiers, which actually hold that water on the microscopic level in solution. And then once your equipment gets up to speed and up to load and operating temperatures, it'll flush that water off of the oil. And then built-in breaking contamination, like I mentioned before, foundry sand, manufacturing residues, any sort of ray cleaning residues. That's why I suggest white balls or any sort of lint-free rag for cleaning, because those particles, they get in there. The real bad actors are where you buy those bags of like ripped up t-shirts and such, or the boxes of ripped up pieces of old clothes that are used as rags. Terrible use of terrible rags for cleaning. Control strategies. So it's a 4-step process. You're going to receive your oil, you're going to put it into storage, you're going to handle it, and you're going to keep contaminants out of it. So set a standard and test against that standard. Both dealers may clean out their tanks if they find out you guys have been sampling. What gets measured gets managed. Sample your oil at delivery. Make sure it actually is what you're receiving. We've had customers before that they order oil and that's not what was delivered to the site. Like, for example, we had customers that ordered a bunch of 15W40 engine oil, and they received 7590 gear oil. Now, they both have the same viscosity, but very different additive packages. So, for example, look at this here, 22-2018. That's a fairly dirty oil, and that's just from the barrel. So, remember how I said that ideally you'd want a gear oil at 18, 16, 13? That's much dirtier. So like I said, up to 8 times dirtier than what's recommended for most critical machinery. Take measures to exclude contaminants from becoming part of the fluid. You got to do this at the main stores and at every individual station throughout your plant. So your main stores have a nice setup like this, and even at your smaller sites, like, or your substations, like even if you have something like a drum topper or just like a drum pump that has a filter on it, something as simple as that, it will make a huge changes. Dragging around a filter cart, I mean, I know that can be a pain in the butt, but filter carts are one of your best friends when it comes to adding oil on site, and we'll touch on that in a couple of minutes here. When it comes to storage, desiccant breathers, quick connects, they're all going to be good things. Right here, I've talked about all the bad things, right? Like what I was saying, like storing drums that have all this contamination on there. Like these drum bungs are terrible. They have terrible seals. When we store drums outdoors, as a last ditch effort, store them on their side. I don't like when we had to store drums outside because it's not ideal. We want to be in a temperature controlled environment for our lubricant storage. All these drum bungs are open as well. So lots of factors going on. Those wiping rigs I mentioned, these cans, and of course our funnels. Remember I was talking about funnels? Like these look like they haven't been cleaned in quite a while, and they're, again, it looks like you can even see some dust on there. I bet you they don't get wiped out before putting into the next piece of equipment. So great lubricants here. They're clean, they're safe, they're expandable. They optimize your storage. Limited access to people who can go in and out. Clear mark landing areas. You're going to want to have a good location. Consider fire and worker safety. How easy is it to work? Your ergonomics. How easy is it to prevent mixing of different lubricants, right? And different lubricants getting stored in different places. Making sure you don't accidentally put barrels and buckets in the wrong places. Now, I talk about having your barrel stored on their side. I can't really complain about the picture of this lubricant. Everything is pretty good. The only thing I could criticize, I guess, is you can see how everything is marked on the walls here. These could be bigger, the labels, and they could be all color matching. And I guess the other thing is you could paint the floor for your landings to match. each of the colors. So having different colors and color coding for lubricants is just that one extra step. So you say blue, okay, I know blue is my Hydro 46 oil, and then you can go from just look for anything that's blue and know that that's how it's associated. And quick connects. The quick connects would not connect to different lubricants or different components. So all these little steps that make a contamination control a big part of your loop program. Now, I know some of you guys are probably further along in the oil journey, and others are further are in the infancy stages. But this is one of the primary things I'm always going to recommend: filtering and color coding. So here's a good example. Like, I've gone to the site a few times, and every time I've gone, I'm impressed with how much they've processed. Now, this photo is a couple years old, and yeah, they don't have a big containment in here, but the whole room is containment. So they have little drip cans. Everything is properly labeled. They have different colors for each oil, which means something. The only thing, again, one of the things I could criticize about this is that all their oil safe containers could be in a fireproof storage. That's about the really only thing I can criticize about this shelving in here. And this is what I mean by color coding. So you could buy these tags and like a yellow circle, Petro-Canada Turboflow 32, right? Then you could have, I believe this was a gear oil, the red triangle or the red diamond. It doesn't matter what colors you want to go with or shapes, as long as it's consistent across the site. There's nothing as a industry standard. These are made by Oil Safe. We have no affiliation with Oil Safe, but I like their stuff. They're great when it comes to these kind of color coding system, excuse me. They use basic shapes and they have everything written out. I mean, you could use basic shapes. You could use Lord of the Rings silhouettes of characters for all I care. It doesn't matter as long as you have some sort of consistency. When it comes to tagging, it's important because if you make it easier for yourselves and lube techs to do their job, it's going to make the program better. Is it better that your lube techs are running programs and making sure that the oil sample data is good, or is it better off them having an end of a grease gun and those kind of things, where these systems can be automated a lot easier? Now, for the equipment that we do have to go visit, label your grease equipment. Like we offer services where we can come and look at every greased asset and say, hey, you should put this amount of grease in this often based upon the operating conditions. Like if you look at an electric motor, it does have the grease amount stamped on there, but does it know that it's in a natural gas plant, or if it's in a coal mine, or if it's in a potash mill, right? For us here, we will offer this service as well, where we can hang oil sample tags on each component. Now, what's nice about this is you scan that component, or you scan that tag, and then you scan your bottle, and then it's registered. There's no printing of labels, there's no writing on lids, there's nothing. It's just scan, scan, done. And then basically where it comes back to, now that we have all our good oil stored, everything is stored, we have everything perfect, right? We've eliminated every sort of contamination source possible. Well, now we need to keep it clean going from equipment or from storage to equipment. Now, these oil safe jugs are great, whether you use these ones or any variation of them. You can make your life a lot easier just by having the proper color-coded oil system in place. Now, with that being said, there are going to be people who just come in and do what they want anyway, and I understand that. I every time I do training, I always get, well, this technician comes in and does this, or operations comes in, they'll empty one of these, they'll wipe it out, and they'll put whatever they want in it. Well, that's what I'm talking about. Controlled entry into the loop room, right? Give them their own oil sample jars that they can do whatever they want with them. They're not part of your equipment that you're responsible for. And as I say, making sure everything is properly contaminated, color-coded, and contamination controls in place. See how easy something like this is to set up. And it's basically filtering at every stage. You get your oil, you filter as soon as you get it, you filter it at every stage along the way. You're going to have the best blue program by constantly doing that type of exercise. And storing grease and oil in these fireproof cabinets. Obviously, something like this is like a picture from a trade show, but it kind of shows the importance of keeping things clean and organized and not just randomly thrown in there in the box with paint cans and other random things that belong in a fireproof cabinet. Have one reserved strictly for your lubricants. And lubricant handling, like when it comes to establishing your program, portable filtration, especially on larger reservoirs, is just going to make your life way easier. Filter carts are huge. I had a site that I worked at for a number of years. They were emptying drums with a hand cranked pump all year long until I bought them these. I'm like, their arms had to be just dead after adding it by hand, like the hand cranking one. I'm like, buy a pneumatic pump, buy a pneumatic filter cart. Then the oil gets filtered, so you have clean filtered oil going from your totes and barrels into your equipment storage. And the biggest thing is costs way more to clean it than just keeping it clean in the first place. And this is one of those breather kits I was talking about that I crudely drew. So you have a sample port that goes straight down, fixed step every time. And just basically some of the health and safety we consider. Oil's on slippery. We got to keep it cool, clean, and dry. Things are more safer to be around when they're properly lubricated. And then filtration, and I'll get you guys out of here in about 5 minutes here. So the goal of filtration, improve our oil dryness and cleanliness, help optimize our oil's usefulness, and honestly, it's going to improve your reliability, and it's one of these things that pays for itself in a short amount of time. Yeah, filters are expensive. I understand that, but this is one of the easiest ways to optimize and like your equipment. This is just a basic construction of a filter. You got that random orientated strand of cellulose fiber in the middle. A lot of them will have like a wire mesh on the outside, and some will even have a screen. So perforated center tube. So different layers of cleaning is going to help improve your equipment longevity and your oil longevity. So you got two main types. You got cellulose, which is like basically paper, and then glass, which is basically going to be like a fiberglass filter. Now, I just touch on this. If you've ever heard that you need a synthetic oil, if you have a synthetic oil, you need a synthetic filter, that's hogwash. You don't. It just means that you have a glass synthetic. I can almost guarantee you that those of you who drive anything that runs a synthetic oil, it's not running a synthetic filter. It is definitely a paper cellulose fiber filter. Two main types. Majority of what you're going to see is like a surface filtration like we see here, where the oil hits surface, and if you have more pleats, deeper pleats, obviously you're going to have more filtration. Now, it doesn't have as many layers, so the torturous path of cleanliness isn't going to be the same as it would be if do something like a compressed disc or depth filtration. The best way I try to explain the difference is take a paper towel and run it under the sink, one piece, and then you take that same roll of paper towel and you try to run it through the side of that paper towel roll, and how much longer it would take for that water to penetrate through to the middle. Now there's two main types, nominal and absolute. How do you know the difference? You'll see something like this, or you'll see the cost of them. Significant difference in cost. Now, nominal filters, they chop about half of the particles of the size of the size will be trapped. So when I say that, like I'm going to do a crude drawing here again. If I can find where my cursor is. There we go. So if I draw this and I got 1, 2, 3, 4, 4, 5, well, it's going to hit that filter. So let's say 3 get through, right? The next time it hits the filter, and we're assuming nothing new is generated. 2, and then 1. So basically how that's going to work. Now with an absolute, if I have 75 on this side of the filter, only 1's getting through. Now that's particles that are 5 micron or bigger. Now when they rate these filters, they're assuming that it's all laboratory testing. So obviously all these tests are done in a controlled environment, temperature, speed, or flow rate, speed, particle size. They're all going to be uniform spherical particles. So constant load and pressure and temperature. Obviously that's not what happens in the real world. So we know particles are going to be different shapes. So something like you could have a particle that's 10 micron in length, but it's only 1 micron wide. You could slip right through that filter, right? Now, filters also, they become more efficient as they plug up, obviously, because they're going to be less media to pass through until they go into bypass, obviously. Now, absolute filters obviously are going to clearly be a better filter. So like our filter rating is that small subscript 5, and then this is our efficiency, 75. So 98.7%. And on the next slide, I'll show you where I get that 98.7. So basically, simple math equation, 75 minus the 1 over 75. Now, most of your filters you see for like a vehicle are going to be about that 40 micron in size. And they're typically going to only be about 40 to 50% efficient. So I'll show you why that might not necessarily be a bad thing when it comes to this. So look at something like this, right? We have 1 million particles that are 5 micron or bigger, and we have a beta 75 all the way up to a beta 1000. And you can see the difference here, right? A 75 to a 1000, it's a seemingly minor difference of only 1.2%. So why don't we just, for the sake of it, we add the automotive filter at 50% on there, right? So we go from 1 million particles we're starting with, right? Now, how about we go through a second pass here, right? Now we're down, that beta 1000 is down to 1 particle, that beta 75 is down to 178, and our beta 50, our nominal filter, that's 50%, is going to be down to 500,000 particles. What if we hit it a third time? Well, now we're down to 250,000 versus these negligible numbers at this point. And we hit it again, 125,000, right? So you could see how quickly we can filter something. Now, 1 million particles is a ton of particles, for one. And it's just to emphasize how efficient filters can be. And again, this is just a surface filtration filter. We don't even get into the depth filtration on this side of things. So for a circulating system, like you would see in an automotive engine or a haul truck engine or whatever, you're filtering the oil up to 15 times per minute. So think of how quickly you're filtering out all those contaminants. And that doesn't even take into consideration for diesels with spinner filters or anything. This is just your typical run-of-the-mill engine oil filter. So is that beta 5 1000 really worth twice as much as that 200, or even 4 times as a beta 75, or 6 to 8 times that of a nominal filter in a single application, single pass application? Sure. If you're going from a tote through a filter cart into your equipment, perfect idea. Good place to do it. Now, if you have a online constant filtration, it might not you might not see the benefits as much with those. So when it comes to wear, though, sure, we can start with our 40 micron, like I was saying, for an engine. Yeah, we can buy one that filters down to 5 microns, and you're gonna logic would indicate you would get 7 times the life out of it. I mean, it's not a black and white like that, but that's just basically logic would indicate that. What about all the other components of that piece of equipment, right? We know frames on vehicles rust. We know brakes fail. We know X, Y, and Z, electronics, everything else can fail. Like, yeah, sure, your engine could be in perfect condition, but what about everything else? You're spending all this money on filtration and constantly changing out filters might not be really that huge benefit to you. And even when it comes to filters, like filter one shows blowout caused by high differential pressure. So what can happen is if you have too heavy of oil flowing too fast, boom, blow the filter out. So we want to make sure that we have the right filter flow rates for our oil and equipment specifications. As well as if our equipment's not properly grounded and we have that metal mesh on the filters, we could cause an electrostatic discharge if the oil is too dry of oil is flowing through that filter, can cause that, and you're basically oxidizing your oil while you're trying to clean it. So again, water can come from free sources, dissolved, and emulsified. Again, if it's emulsified, it's going to look cloudy. Filter your oil. Help get out the water. Help get out the contaminants. Make sure that we are storing our lubricant properly. All these factors is going to be a huge first step before sampling, before anything. Contamination control. As soon as that oil barrel of oil is received on site, making sure that we have all the processes in place is going to be a huge benefit to that. I hope you guys enjoyed the last hour. I'm sorry about the technical difficulties getting it started at the beginning. If there's any questions, please let me know. I can stick around for a few minutes until everyone drops off and go from there. All right, nothing. All right. Well, I appreciate everyone's time. Thanks for joining us today, and hopefully we'll see you for the grease seminar one that I have in a couple weeks. And hopefully we can see some of you guys in Dallas or Edmonton at our training sessions we have for the public sessions. If you guys have any questions on that, please do feel free to reach out to myself or one of your account managers, and yeah, we'd be happy to help you guys set up for that.